a slightly different question. It says on part C, what is the probability that heads comes up no more than twice? So the probability X is heads, the probability that heads comes up no more than twice. So that X is less than or equal to 2. Want the probability that X is less than or equal to 2, no more than twice. If you really think about this, the probability that X is no more than twice is really the same thing as the probability that X equals 0. The probability comes up 0 times, plus the probability it comes up 1 time, plus the probability it comes up 2 times. Because it's no more than twice, so it could happen twice, once, or 0 times. Now, this problem looks a lot like part B, except it's just 3 versions of part B. You calculate each piece on its own. So the probability X equals 0, maybe some people are already able to do this, so probability X equals 0 is equal to 5 over 0. This is the combination. Number of trials, still 5. How many successes? Well, I want 0 successes. Times probability of success, 0.4, raised to the k power. In this case, k is 0, times 0.6 raised to the n minus k, so the 5th. This will give you a number on the calculator. This will give you some number on the calculator.
Would it give you the right answer?
Then you would have to do probability that X equals 1. Well, that's going to be 1.4 raised to the first power times 0.6 to the n minus k, that'd be 4, equals something. And then you want the probability that X equals 2. Well, the probability that X equals 2 is, again, there are 5 options. We only want 2 of them. And we want to succeed twice. And we want to fail 3 times. And so these will be 3 numbers. Then we just add them all up. Let's go ahead and do that. Karina. Mm-hmm.
Okay, so why is it left A? So like this 0, 1, and 2. Why isn't it the same thing as the 0.6?
Because it says 0.6 to the n minus k on your sheet, right? So here's n minus k. 5 minus 0 is 5. This is just k by itself. This is k. You good?
I have a question.
Yeah, Dex?
Do they have this in calculus?
No. So the answer you should get, and I didn't do it all individually, is 0.6825 once you add them all up. Once you add up all 3. 0.6825 once you add up all 3. Please verify that you're getting that.
It's going to take a while. Look at all that. I'm barely on the third wheel. They say calculus.
It's a good thing we have 3 days for this.
This is going to take a year. At least.
So let's make sure we get this, then I want to do one more thing. And again, if you don't finish all of these, as long as you understand where this comes from, the calculator work is doable. The calculator work is just plug and chug. Did anybody get this yet? No.
I did.
Okay. Jennifer, you got this? And by the way, you can do this all like on like one big chain. You could do this plus this chain plus this chain if you want. Better to do that as opposed to rounding on the way. Do we go to 105? So you're going to tuck your shirt in. Sir?
Uh-oh.
Mm-hmm. Yes. Because you did 4 to the first power, 6, not 0.4, 0.6. Okay, so let me not belabor this point because I do want to do one last thing here in the last 4 minutes that I have, and this is the crucial thing that I'm told from last year's AP Stats teachers at other schools that everybody struggles with. So we need everybody with me for the last 4 minutes. Like, literally, put the calculators down. Please put the calculators down. Again, you guys can do like the plugging in later on. It's no problem. Okay, 1D. Like, this is literally where people struggle. So it says, what is the probability that heads comes up at least once? At least once. Let's try writing that. Just try writing this piece on your own for what is the probability heads comes up at least once. Try it. If you need to look up, that's fine. But here's what I'm going to get. So if you're trying it on your own, verify you got what I got. The probability the head comes up at least once, which means once, twice, 3 times, 4 times, 5 times. Shamar, did that help? So really, folks, we could solve this way. We could say, well, this is the probability it comes up once, plus probability of 2, plus probability of 3 heads, plus probability of 4 heads, plus probability of 5 heads. That would take a long time. We saw like how long it took to do just 3 parts. Imagine doing 5. Imagine what happens when it says we want to flip the coin 20 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 20. It'd take forever. There's a much better way to do this. If we just think about it for 1 second. The probability of getting x greater than 1 is the same thing as this. Does anybody see why that would be the same? I'd love for someone to try the explanation, and then I'll give it. Jennifer, you want to try it?
Isn't it because like the whole thing is going to be the 1, and then since it has to be greater than 1, it can't be equal to 0, so that's where like anything above it equaling the 0 is the possible answer?
Okay. Were you going to say something different, Eddie? So what we're saying is the probability of getting 0 heads plus the probability of 1 head plus the probability of 2 heads plus the probability of 3 heads plus the probability of 4 heads plus the probability of 5 heads has to equal 1. Hold on 1 second, Mom. Has to equal 1. The probability of 0 heads through 5 heads must be 1. Those are the only options we have. And I really want to know this. So how do I isolate this? Let's just minus the probability x equals 0. Let's minus the probability that x equals 0. So what do we have? This goes away. So we have the probability of x equals 1 plus probability x equals 2 plus probability x equals 3 plus probability x equals 4 plus the probability that x equals 5 equals 1 minus the probability that x equals 0. This is easy to calculate. This is just this. And then the answer is just 1 minus that number. Let me take questions. Tamar? Make sense? Dex?
Why is it 5?
Because there are only 5 flips of the coin. It says that on the top. Okay, guys, so hold on. So, for tomorrow, on the back of the sheet, the only thing I want you to try for tomorrow is on the back of the sheet, problem 3, where it says at least once problems. Use this setup to try problem 3. We're not going to grade it. We just want people to try it. So problem 3, A through D, and tomorrow we'll just pick up here. A through D, but do not lose this handout. We're going to keep it going tomorrow. Great job, guys.